Anyway, I think most people know who I am, Steve Rostedt. I plan on talking about this little thing that no one has any complaints about. But let's start off with, in the beginning, Linus said, let there be scheduler. And it was a single run queue and had a single run spin lock to handle it. On scheduler, it would search the entire list of all tasks that are runnable for a goodness value. Uh-oh, now I'm in trouble. You come in, I started already, but I'm just going through old history that, someone's behind you, someone's behind you. So, in 2002, Inge Molnar presented the 01 scheduler, which introduced per CPU run queues. This was like drastic improvement of the scheduler. You didn't have a single run queue, but remember this is 2002. Pretty much everyone had a uniprocessor system, and a busy system had like 10 tasks on it. Let's see, it used a bitmask logic to find the next available task to run, because you could just do a find first bit, set bit or something to find, oh, here's the next, the bit mask would be set, like which queues or which priority levels are set and which queues are there, so it could find the information. Whoops. And so it had an upper bound to pick the next task. So that's where the 01 scheduler came in. And but later on, as it got older and moved, we had all these heuristics added to the scheduler because we wanted to differentiate between interactive tasks and batch tasks and tasks that just were running for a long time. And the heuristics turned kind of like, they always had to kind of add more corner cases. And it kind of built up and built up. Kalivas came in with an idea of making a pluggable scheduler. So this would allow for different scheduler implementations that people could try to, say, hey, how's this scheduler implementation work? How's this one work? Compare different schedulers. He had a way of creating a public and private data structures, so code could, among all schedulers, could use the same code, but then a single scheduler could use a different scheduler, and you could focus on specific, like a scheduler could focus on a specific task, and you could switch between them and such like that. But Inge Molnar, eventually kind of said, I believe that by compartmenting in the wrong way, we are killing the natural integration of X. We end up with 5 or 20 bad generic schedulers that happen to work in one precise workload only, but there would not be enough push to build one good generic scheduler, because the people who are now forced to care about the Linux scheduler would be content about their own specialized schedulers. Sounds familiar? Anyway, then Khan, in 2004, came up with this new scheduler called the staircase scheduler, which replaced all the heuristics with multiple run queues per CPU. So one CPU would have multiple run queues at different priorities, and basically the higher priority ones would start up first, and when it ran out of time to fell to the bottom one, tasks would then slowly be pushed down the run queue and then would interact with the lower priority tasks. And when it got off to the last run queue, it would then go, let's see, what's this? Run queue, it would go back to just one below the max run queue. Then it would jump up and it would have 2 slices. I mean, you could go look at the link there and read all about it. So basically when it ran off, it would jump off to the one below recrew with twice as long times. It was an interesting little feature. And it, people said it was, worked well. And what happened was about interactive tasks that would always stay at the top of the run queue, because if you when it did this recalculation, if you're sleeping through the recalculation, you got replenished, so you would always end up on top, which basically, so if you ran a little bit and then was off the run queue, or ran a little bit, ran off the queue, you'd always stay, when you came back onto the run queue, you were always at like the higher priority, which means that interactive tasks that usually just run on an event and then disappear and then run on an event, they actually always stayed up in the higher priorities. Then he came back with, in 2007, right? Yeah, March. This is important. March of 2007, he came up with a new version of a rotating staircase deadline that had actually, let's see, it had quota to the priority level. So the priority level, as the CPUs ran on the priority level, it would actually run out. So when it ran out, all the tasks at that priority fell to the next lower priority. So actually the priority levels had its own run queue or quota that it could actually run out and fall to the next. And yeah, when everything falls off, it goes into an expire queue or into like a duplicate run queue table that gets filled. And then when it finishes over, it does a swap like the old way, like the original O1 scheduler kind of did. And then when it turns to the new one, and again, this is the one where I guess when tasks sleep through the rotation, it again is at the top and it comes in pretty quick. April of 2007. So after this was kind of released and people were discussing it, Ingo disappeared for 2 days and came back with a new scheduler called the Completely Fair Scheduler. And right in the middle of all this back and forth going on, and this did away with run queues basically completely, or the array of run queues, or a run queue array completely, came up with the RB tree. Tasks were added by their wait time that was put on there. So when a task should be running, it gets higher wait time, and then that gives it a higher priority. He modularized the scheduler, and a lot of people were saying, "Oh, you modularized it." That everyone was asking for. Well, not really. All he did was basically break up the sched.c file into multiple schedule files. So there was like a sched fair, sched rt. Before it used to be just sched.c. So, and then he also added things like methods for the functionality, pick next task, and all that was added. 2009, Khan came back. First he disappeared, and then he came back with the BFS scheduler. And yes, the F stands for exactly what you think it stands for. So it went back to the original single run queue that was from the goodness run queue things, which actually was interesting because one thing that the single run queue did, it actually made it so he got rid of load balancing altogether because it would always pick the best CPU for the things run because all the CPUs were running. Also, he also came up with this new thing called sched ISO, where a task could say, I want to be at a higher priority than other tasks, but all the tasks at sched ISO only get like a 70% of the CPU. If they go beyond the 70% CPU, they get dropped down to sched normal again. And this allowed any non-privileged tasks to have RT behaviors. And this was tunable as well. It actually implemented a earliest eligible virtual deadline first algorithm as well. And one thing he said was he never got around making it work with cgroups, so he just disabled cgroups when you ran this. Yeah, see? So, hey, you like the BFS scheduler. So he came up with V2 in 2011. This time, because one of the complaints was it was a double linked list that was going through, and the double link was slow, so he re-implemented it using skip lists. You could go and read about skip lists on how they do it. And also, it has like an O1 lookup for the next task. So it improved the speed of the tasks. It did have some of the complaints about the scheduler was it was slow to pick the next task. And also, this also added a little bit more awareness of the topology of the system. And then eventually, in 2016, he came up with the multi-queue skip list scheduler, which is basically the BFS scheduler with queues per CPU. So he got rid of the single run queue for all tasks. He said that would only get about 16 CPUs before it 16 logical CPUs before it starts having problems. This one could handle any amount of CPUs because it had each CPU had like a BFS scheduler type on it. But he actually, he didn't have an EEVDF. He had hit what was called the earliest effective virtual deadline first. It's a little bit different than eligibility, because eligibility means if you don't have eligibility, you run. But basically, it was the algorithm seemed to be, it was still run, but effective deadline. It was kind of complex to, I'm not going to try to explain the difference. It's subtle. But now the thing is, we ran this, and actually it was quite impressive how well it works on a desktop system. And I'll bring that up from slides that we had 2 years ago here. Now in 2022, this thing called the Extended Scheduler class came out, or also known as SCHEDX. It was a new way to have pluggable schedulers. And you can now write your own scheduler, basically the entire scheduler from scratch using eBPF, as everyone knows. And one thing is SCHEDX always runs below the SCHED tasks. And now the latest thing we have is in 2023, Peter created what's our today's earliest eligible deadline first scheduler, replaces CFS completely with EEVDF. Smaller deadlines give you better latencies. Eligibility, I don't know if okay, 2 years ago we did our benchmarks, then Yusuf, who I thought was great, he left Google, went to Microsoft, and we have not had someone fill the void of his work. So we kind of lost a lot of our benchmarks. So we're going to do a lot more benchmarks. And we haven't looked at the latest and greatest of the eligibility. But one thing we did notice was eligibility was hurting us, because we had tasks that were real-time, or not real-time tasks, but tasks of higher priority, because it ran a little bit longer than it, got more of a time slice. And I know now you have, like, when you sleep, you kind of get your stuff back again. I think that helped, but also I think there was also patches. I don't know, did you write? Someone was writing patches about on wake up. The wake up ignore, like when you got woken up, you kind of like ignored the eligibility on wake up or something. It was sort of like there was something patches there. When we disabled eligibility, we got much better latency performances than when we had eligibility on. So I don't know. I don't think we've done the testing with getting the eligibility back. That's something we have to look at. So basically, the scheduler has several constraints. Fairness, obviously, is one of them. Latency of interactive tasks that we care about. Task affinity, that's something that schedulers have to care about. Power management, we have different views of like big, little, and idle, making sure things are idle so you can save things, CPU ISO sets and stuff. So back 2 years ago, we presented, Yusuf presented this little graph. This is some of our tests that we have at Google for Chrome. Basically, it runs a bunch of things. Some of the times it'll run like meets and such, and it measures like if you have a dock up and you're typing the dock, what's the latency of when you press a key to when it actually shows up. The other one is mouse latency, which is like when a mouse goes from one window over the next window of the Google Meets, when the when the mouse goes over it, from when the window actually reacts and shows that, hey, there's a mouse here, that you can see that. And drop frames is how many frames are actually being dropped during the meets and everything else. Try to explain, this is the last graph that we had. The way to the left was, so we had this thing where we try to use cgroups to try to, so we care about foreground and background processes. Think of it this way, it's on Chrome browser. Foreground is the tab you have open. All the tabs you have that are not open are background processes. And whenever you click to a new one, we switch everything over to that. We found out that actually getting rid of that and kind of, or at least we used to have like a hierarchical C group thing. We kind of got rid of that, and we found out we actually had better performance when we got rid of it. The C groups were actually causing overhead to us. So the first two was like the C groups thing. The next two was when we just said, okay, put everything into the root C group and run everything. So you can see pretty much all the latencies drop, and the drop frames all dropped just by. So the first two was the with the C groups, and the very first patch, you'll see 2C. That means it was a 2-core processor, and the other one is a 4-core processor. Like I said, our Chromebooks are actually less powerful than your phone. Just FYI. It's also a lot cheaper than your phone too. So then we have. Joel had a way of like putting our certain threads, like we have the renderers that actually draw the stuff. We made them into real-time tasks, and that kind of helped out a little bit. That's the next two set is the real-time tasks. This is the EEVDF. This is 2 years ago, EEVDF. We haven't tried this with the layers, so I would take that kind of with a grain of salt because this is 2 years ago, and I would like to make the same graph with the newest version of EEVDF with the wake-up latencies. Last, if you remember, I had this little sched high thing, which was a way to make kind of like the sched ISO, where I created a way that processes could have a sched other that's a higher level than that would preempt and act like sched other tasks, but not real-time tasks. That was the last two. And what's really interesting, if you look at the very last two, that's the MuX scheduler with no changes whatsoever. So it actually performed really well with no tunables. Yes?
The EEVDF one, was that inside a C group? Or?
No, okay, so the first two were C groups and the last two are all just no C groups. So we just wanted to show this is when we originally looked at it and how we saw how bad things were, just getting them out of C groups would actually improve things, but then everything else is just even. So this is why I'm like saying, one thing that impresses me about the MuX scheduler, it's a really simple scheduler. If you could look at the code, read the code, and understand it really well. There's not much complexity to it. So my general conclusion is the scheduler is hard. I think most of us realize that. It tries to do everything for everyone. Could the scheduler be simplified by limiting the requirements of the scheduler? That's sort of the point that I'm making it. So I'm like looking at least 4 types, but there's could be multiple types. And starting with you have the server, I look at the environment. I don't want to say, oh, I have my particular, someone said, oh, you have a SUSE scheduler and a Red Hat scheduler. No, it's the environment. The environment would be like a server scheduler would be like you have multiple users, maybe multiple VMs, whatever. Define that. That's the type of environment that has certain constraints that they care about for that situation. Desktop environment, what I would say is you have a single user. You only care about the one user, but could have multiple applications going on at the same time. What you care about what that user sees. Phone environment is mostly like you have one user and one application because it's usually just one. And some people say, well, you could do split screens and stuff. Yeah. Who does that on their phone? Anyway, and then I would call the embedded environment would be you have an environment where you have no users just taking events, and so that could be very, very simple. So my proposal that I'm sure is going to be shot down, but something I might just talk about, or something I'm looking into, is called scheduler governors. I don't call them plugins. Reason why I'm avoiding the term plugin is it's one thing that the original sched plugin everything allows is to be able to create a module and create your own scheduler and plug it in. This would be something that would not have any export symbol at all. No modules will be able to create their own scheduler. My point here is the fact that schedx is here. And what we're seeing with the problem with schedx that a lot of people were worried about, and some people said it won't happen, but actually we are seeing this, is you get people that says, I'm going to write my own scheduler. Kind of like what Inga was saying, you're going to have a bunch of people that writes their own scheduler, and it's not really being shared as much as you would like it to be. I think we have several schedulers within Google itself. This is the idea of saying, hey, we have several people with the same environment. Could we actually bring it back into the kernel if we're able to kind of modulize the kernel and say, if you have this environment, we could focus this scheduler. Can we simplify the scheduler code for a single environment and remove requirements for we could keep the main scheduler. So like I said, if we had this abstraction, one thing that would have been nice is if when Peter created the EEVDF scheduler, it would have been really nice to have one kernel that you could switch between the CFS scheduler and the EEVDF scheduler just to see how things are reacting. Are there regressions? Are there not? There was no easy way to do that because to switch the scheduler, it was either you had to recompile the entire code with EEVDF or recompile the whole thing with CFS. It was not an easy switchover. And as EEVDF got better, because we did find regressions and whatnot, we were still not able to do the switch to check things out very easily. If we had sort of this interface, we could have actually done that. And as EEVDF improved, we could always compare it to different, the old schedulers and see what regressions were there. So the idea was, like I said, of this, my proposal here is if we just abstract things out, we can actually make it a way that you have a scheduler that you can focus on your single environment And for that, we could still keep everything the same as all, like, still have the main general scheduler if that's what works for you. But if you have like an environment that's set, like a simple environment that you don't care about everything else. And another thing is we have power management. You have power management issues. I mean, that could be another environment. So I don't plan on making 20 different governors. There might be, but the idea is just a few environments that people could come back and work together on their environment. Have all the phone folks work on the phone scheduler. And one other thing is that I want to throw out, and this might, I don't know, we'll see, is Peter doesn't scale. It really, I watched the mailing list. I tried to skim through the schedule patches that come in. I want to read the scheduling patches, but I have other things internally and whatnot to do. I just try to skim as much as I can because I'm interested. Peter has to read them, because he's the maintainer. He's looking at this. He's in charge of everything. Now, if we were able to do something like this, we could have Peter like the general focus on one thing. And you could get like, hey, have an Android maintainer or one of the Android people say, okay, we're going to focus on the phones, and I could actually look at the code and make sure and run tests and run benchmarks specific for the phone. For that scheduler would be just for that phone. You have a desktop, for a desktop scheduler just for that. You can actually get multiple maintainers that are now specialized in that field for that or that case, and they could develop all the infrastructure around to help improve it, and not just have poor Peter every time he's saying, hey, we got a new feature, and him going, oh. Just as he did earlier today. So, but we can still have the complex logic if you want it. And
this is basically the situation we're already in with the BPF stuff. There's a whole pile of BPF schedulers that do their thing. And I mean, they can integrate with power management, they've got the hooks. And there's probably a talk later this week about at least one of them. They have their little maintainer and then do their thing. It's just that there's so far been no feedback. I mean, they do their thing, they're happy, and no contributions otherwise.
And this is actually what I'm trying to fix, because actually I like the idea of pluggable schedulers. Honestly, I think SCEDX is great to tweak the scheduler. I don't think SCEDX should be creating schedulers. Ideally, we should have like a real scheduler that could be tweaked with eBPF. This is where the thing. SCEDX, I would say SCEDX could still tweak any of the schedulers. But really, you want your own scheduler. And then it'll be upstream, and also it could share code.
On the sharing the code part, I just wanted to mention one thing, that a large part of SCEDX is in the kernel. So there's like default select implementations for finding idle CPUs and other stuff. So it's not like it's entirely people going off and doing their own thing. A large number of them rely on code inside the kernel, inside ext.c to implement their scheduler. So.
Like what?
It has a number of building blocks.
Yeah, building blocks.
You can connect them, or you can just not use them and do
Right.
everything with BPF.
Now, my question is there also, is there a case of the old like interrupt handler of the architectures, where I create a new architecture, I need an interrupt handler, I'm going to go copy x86 interrupt handlers and say, hey, what's it called, and just redo everything, and then you might create or there might be a bug fix in x86 interrupt handler that you don't get because there's 10 different duplications. Thank you, Thomas, for making the interrupt handlers into kernel, like a generic infrastructure where everyone just has little hooks into things like that. If we can move that way.
But there are really no hooks. The only abstraction here is that you have drivers per interrupt controller,
Right.
which is hardware specific, so you can't get around that, but everything else is generic. There are no hooks in it.
Well, my hooks was like the generic, basically handling the code. But no, the point I'm saying is if you had, like you...
We had a lot of non-architecture specific nonsense like interrupt handling, timekeeping was per architecture, everything. Got rid of all of that. And I mean, generic infrastructure is always the preferred way to go.
Right. So, I mean, I don't know if BPF is having all the building blocks is just going to be now generic and everything. I'm just like throwing this out. I mean, we could keep this or not. One thing I would like to do with the scheduler, because one thing is the scheduler is, I mean, when I worked with it, it's like all over the place. Like when I tried to take the fair, there's hooks into like fair kind of like leaks into core and leaks into idle, or idle leaks into fair and whatnot. And it's probably for optimizations and such. But if we could kind of like define the scheduler a bit and make it more abstract, and like one thing is if we were to do this and make clear interfaces of what things did, I think actually just the exercise alone would actually hopefully simplify the scheduler, so more people than just Peter can really understand the entire scheduler. My goal here is to basically to simplify things.
There are a few.
Yeah, I know, but I know. Just say if a bomb, if Russia were to blow up a bomb right here. The scheduler, like basically right now, the Linux scheduler would just be, no one would understand it.
So, Steve, when you say governor, do you have like some sort of a sample of what governor should be doing? I mean, what should remain in the core and what should the governor do?
Well, no, the reason why I use the term governor, I kind of thought of power management governors. The fact how, it's like, don't blame me. No, because the idea is to get away from the idea that it's a module. Like you could just plug in like a pluggable scheduler. I don't want it. It's like, this is like my environment, because power management is kind of like, here's my environment. I'm going to change the...
Yeah, but the idea is kind of different because we still use one governor for everybody, and you can just use different governors depending on your taste or whatnot.
Yeah.
But it's not like there are server specialized governors and client specialized governors.
But that's not true. I mean, at least back in the day, you'd have the performance governor versus the power save governor, and I think that's what you're referring to.
Yeah.
As opposed to...
It's like, how, like, what's the system you invite? What type of system do you have? Because this is on the system level.
So those are the special cases that pretend to be governors.
Right.
You know.
So what are you suggesting? Are you suggesting something that's switchable at runtime? Are you suggesting...
Yeah.
Well, here's the actually, I have... right now, like I said, I just wanted to look at the code and start at making things a little bit abstract. I haven't gotten that far yet, but from my own vision is like, it could just be at boot, you determine at boot and you don't switch it there. Or it could be, you could determine it like you boot up and you have user space saying, oh, we're in this type of environment, we'll use this thing. So yes, it could be switched, but that's not going to be a priority of switching during runtime. It could just be at boot up, it could be, whatever, or even a kernel option, maybe it could be that way if we had to, or it's, yeah.
And then I'm just pulling this number out of my backside, but essentially what you're suggesting is 5 different schedulers in a kernel. Now, they could have some common core part, but otherwise specialized but they're 5 different schedulers.
Yes.
And not...
Yes, exactly that.
And so what you think should be specific and what should be generic? I mean, if you say you should have which kind of decision the government...
Okay, so we had a little bit of, at Google, we had a little bit of a reorg that changed everything. So my focus, I was supposed to start working on this in January, but my focus I'm still not even able to work on it yet because of things, Joel, about. So I was hoping to actually, one thing my exercise when I do, I was going to implement a desktop governor using the MuQSS scheduler. And by doing that exercise, I was hoping to learn where the definitions would be. So basically, the only way to answer your question for me is to actually go and do the code, take a completely different scheduler, put it in, and make it so I could switch between schedulers. And that would give me the answers to this. I haven't been able to work on that, so I can't answer that question.
That's true.
So I don't know if you have partially answered this question, but would you imagine taking 5 copies or 4 copies of fair.c and optimizing each one for the...
But 4 copies of which?
Fair.c or 4...
Oh, no, I was not going to do that. Like I said, I was going to start with a completely separate scheduler and implement a different scheduler. Actually, one of the little exercises I was doing was bringing back CFS. and see if I could get CFS and EEVDF just to get the interface, not to say that this is a desktop scheduler, just to learn where the interfaces would be. So we could actually switch between different schedulers. So that was like my goal was going to be to do that.
So why can you not follow the same model that the scheduler follows today, in the sense that you have sched fair, sched FIFO, sched RR, right?
Yeah.
I mean, these are three different schedulers.
No, that's not three different. One thing, by the way, this is only for sched other. Sched RR, sched deadline, we're not going to be touched.
But I'm not talking about touching them. I'm talking about using a similar model, right? Where I've identified, okay, I need to be able to pick a task.
Yep.
I need to be able to...
Yeah, I mean, the sched core still be there. Yes, the sched, and it just modularize it more. Yes, I would think of modularizing it more. For when I implemented this, I would be like one thing my goal is to try to share as much code as possible.
So I think what you're saying is that some of it we are doing today as well. Because, for example, RTN and deadline, they are actually using the same interface, which is the scheduling policy, and then in the policy you implement what the scheduler is actually doing. So
Scheduler, if you don't use CFS, then CFS EAS, then it's a different scheduler.
Yeah.
Basically, if you use EAS, then it is different. So, even in the desktop use case, use two different schedulers. So,
the problem for me is like with all this sharing, it probably, I mean, this is one code base is better. For instance, you said power management scheduler, right? Like when we just care about our power management things, we still rely on things which gets introduced because of EEVDF, for instance, the schedulate stuff. So you really have to know everything to even your special scheduler that it works great. You have to understand everything. So the only thing I see is to do more review on all those patch sets.
Well, that's only if you care. Like you said, you could say I don't care about EAS on this thing. I guess idea is
we can't just concentrate on ES, right? We have to concentrate also what's going on EEVDF, because they all like intertwined. Like a new feature in EEVDF can have a bad influence on our load tracking, for instance. And it's for us, it's important to figure this out as soon as possible, right? Like,
and on the other hand, it is true that you don't care about the ES in certain configurations of the system, like the server with 1,000.
Yeah, those specific like leaf nodes of functionality, but the basic stuff, it's all interacting, which is
I think that's kind of what he's trying to say, right? But let's say he brings in MuX. It doesn't have the same EEVDF functionality, and maybe the folks who are using MuX don't care about ES, so they don't introduce that functionality in.
It's basically you're defining a requirement thing and say, I only care about this requirements. And then you could say, if you want the generic, then you have to use the generic scheduler. If you care about that, then you use a generic scheduler, or like, because there's going to be a default thing that's probably going to be what exists today. And this is just, I have a specific environment, I can easily just switch over.
I don't even know what the generic scheduler is today, because as I said,
it's EEVDF.
But as I said, EAS changes things entirely. So it's not like you can even say that what really is generic.
It doesn't change it entirely. If you
EAS on your servers.
If you overutilize EAS, gets turned off automatically, right?
Yeah, it's mostly wake-up path.
Yeah, mostly the wake-up path when you're underutilized.
That's true, but then again, it changes the behavior.
Yeah, I mean,
in that specific case, right? And then, it is also true that you don't even turn it on in certain environments. At all.
Yeah.
Right? So
that's like a sched feature, right? Like sched feed, whatever.
Also, there are things like I talked about, like async packing that is turned on demand, basically, because we happen to like it, like on certain configurations of the system. And it is not used elsewhere. And there are other things like that. So maybe, I think you have a point that, maybe it would be good to think about, like, what's the basics and what's the extra stuff that's are added because, somebody needs it or something.
Yeah. And the thing is, this would also, if we make a clear interface, I know like even SCEDX might be able to hook into it, so you actually could probably write all the plugins for doing it. SCEDX could probably. I know you had your hand up. Do you still have a question or anything?
I actually wanted to point out that this is affecting sched normal, right?
Yes. Yeah. So this is only affecting sched normal, and this actually you could probably even say I'm going to. Maybe this would be a plug with it, right, to make it easier for SCEDX to work. But also, one thing that might be nice would be it might hopefully make it easier for academia to actually modify the scheduler or just say, hey, since I have these defined interfaces, I just plug this in and everything will just work. There's not as much dependencies between like CFS or EEVDF into SCED-FAIR and like that you could just kind of plug it in, that you might be able to get more academic papers and stuff.
That's already true today.
Yeah, yes, but it'll be easier.
You could just define your own sched class and
right.
But again, like, if we only are, for instance, from ARM, we are only caring about like power management scheduler, right, and all the rest, then we do need like massive regression testing on the base if we don't follow the discussion anymore.
Well, I just threw out the little Freudian slip there. I just threw up that idea. No, about the power management. That's just one thing, like just saying one requirement, just in case, because it was kind of brought up earlier. But my thing is more or less, I'm looking at more or less how like latency sensitive tests or I'm going to be very selfish. I care about basically the desktop environment, and that's it. And this is where I've seen the biggest pushbacks, the biggest complaints, the biggest everything came from the people saying the desktop environment is not like people are like, who play video games, people who watch movies, do recordings, stuff like that. They seem to say that the experience, like when they used cons, they would always say, hey, it just seems to be better. And there wasn't a good way to benchmark it's smooth. Like it feels smoother for me. Going back to this kind of shows maybe this is the reason why things look better. Because this is where we actually measured drop frames. We actually measured the latency of key presses and stuff like that. And we actually had really good results with the MuX scheduler, which is what people came on and said, when I compiled this, it just seems smoother to me, but no one had benchmarks to prove it, to say, show me how it got better.
Okay. One thing which bothers me about this whole discussion for a long time is we're often trying to just, hey, let's come up with a new scheduler to overcome the shortcomings of the existing user space. If you look at other operating systems, and I have to point to Apple because they're doing a really good job, they're not rewriting the scheduler every other day just to accommodate for shit. No, they're actually doing a good job in looking at the overall picture and actually making the applications use the facilities the scheduler provides.
And they actually, right, they actually came up and said, here is your API, they actually defined it.
And they have, and I'm coming back to this thing, what we're debating for 10 years now, they have a really good interface to let the application express what they want.
Yes.
And they are taking this into account into the scheduler. But we're just debating this and getting nowhere. And then we need new schedulers because we can't actually provide an interface for applications to tell the scheduler what's up with that. You aren't just solving the problem at the wrong end. You have to have a holistic solution. It doesn't work.
Right, and I said...
For your particular use case, press the key and see when the freaking video shows up.
So basically, we brought this up too, and I think there's been work. Keith, whatever his name, he's actually from, I can never pronounce his name. Yep, who is working on a quality of service library based off of the Apple work as well. We're trying to come up with a way of how do we take that and define it for the knobs, but we don't always actually have the same knobs and everything else. And yes, we could do that.
If you look at actually, there's publications about what they do. I mean, they take the parameter set which is given by a particular application, or it's even provided by a system configurator.
Well, the thing is, Apple defines that interface.
Yes, they have an interface.
Right.
You can either use it in the application directly, or the system configurator can say, hey, this is the profile I want to create. This is the property of application A. And it takes on the phone, they take different parameters as on the desktop.
Yes, I know that.
But on the phone, we need to be more constraining the power consumption of the student thing. On the desktop, we can operate more freely and give it more whatever other properties.
And the thing is, what I'm told, I haven't actually seen the interface, so I don't know it, but people have told me this before. Maybe like you looked at the interface set up for that. I mean, it's more, but it's very actually a simple interface. It's not even that complex.
It's not horribly complex.
Yeah, I thought it was more like
wasn't it proposed on the list as well?
Yeah, it was.
The issue was that we don't want to put policy in the schedule, and that was the argument, right? Like our kernel is not specific to, like the Linux kernel is not specific to like a use case in that sense. Like we don't want to bake policy.
Yeah.
That was our argument.
So I'm not against doing that. So we actually have been helping people do that too.
Make policy at all. It takes information provided by user space and computes out the proper tweak of the parameter set. It might fit or might not fit, that's a different problem. But what we are doing, we're trying to come up the special scheduler with the special heuristics to solve a problem which we don't have any information about. No, then what Stephen is proposing is basically putting policy into the kernel. Because Stephen goes and says, I need this solved. So I write my mock-up scheduler, which exactly solves this problem, which means he puts policy into the scheduler. Instead of having a well-defined set of tunables, which are exposed to the system configurator or to the application, where the application can tell, these are my requirements, these are my properties, I'm running periodically, I need this runtime, I need this kind of deadline thing, even if
Wait, I don't know if does Apple give those requirements. I thought it was more or less it's more general. It's more general. I don't think it's.
I'm curious between there is the user space application, and usually they just want to be quite dull, interactive or background. And then there is the kernel of the scheduler interface. But in between, you can do a lot of things. What we are not doing right now. We are expecting the application to know exactly what the NICE is,
I'm not sure if it's
so we need something in between.
Also a bit orthogonal problem. So I agree that we lack a way to better express directly from user space to kernel space requirements, but we also probably lack the flexibility
for the case now is actually trying to crystal ball what the scheduler should do.
I agree with that, but I'm also wondering if we are also missing a way to dynamically, more flexibility in implementing a different, policy based on the additional information. So that might be two problems that we have.
Yeah, I mean the question is, do you end up with actually different policies, or do you end up with a different parameter set to a generic implementation?
So I kind of brought up this one thing.
I agree there's limitations to that, but right now we're just reducing limitations.
One of the things actually, because I'm just throwing up these ideas, I haven't started, but one thing actually talking with Case about doing the lib quality of service was implementing a scheduler governor in user space, where it would actually pass the parameters down saying, yeah, I'm in this environment, and it would actually say, it would pass the parameters to the kernel saying, could you operate in this? And I was like perfectly fine with that. So the idea is that there's different environments where you're right. If you don't want it in the kernel, bring it up to user space, but we need the interface. So I'm not against what you're saying.
You need the interface, you need a well-defined set of information,
and
that's expandable.
Right.
And then, as I said, if you look at that how Apple does it, it's both there's a very non-complex, simple interface applications where they can advertise their, hey, I'm this, I'm doing my periodic, and that's what I want to do. And there's a more complex interface at the system level where a system-wide configuration can give additional and more informed information and say, hey, restrain these. They shouldn't be allowed to take a lot of power, and because we're on the phone and we don't care about this thing, and where we have two levels of configuration.
Yeah, that's what we were looking at.
End up with a coherent set of data which can be fed into the scheduler, and the scheduler can act on it.
Yes, and we're working on a libQOS that actually is supposed to try to implement this, and we're looking at ideas, but it's actually, again, it's not easy, and it's trying, how do you map this information? I know, I'm saying, but right now, does our kernel actually have the interface to handle it?
It's easy, but we're debating this for a days now.
Yes.
But for the
2 years.
The conclusion is always it's not easy, but we're never going.
Yes, I know.
But kind of, we think we need both, like as Yuri pointed out, like it's kind of orthogonal, like we need a better interface, but we may also need a way to do easy experimentation, I guess. So,
wasn't that what SCADX is for?
Yeah,
yes.
I'm saying, yeah, that's the
so,
thing, like, but there's also maybe something in between, I don't know, the governor could be, I think. The other thing that I want to mention is, what do you think, Steve, about having the different governors inside SCADX, but not as SCADX schedulers? Because SCADX itself has a built-in scheduler, like the default one. Instead of having a single default one, how about having multiple default governors? What do you think about it?
You mean inside, would it be like in C or something at SCADX contract, or is
so
it?
in SCADX, you can have like an empty BPF scheduler.
Yeah.
You can load that, and that will switch into the default SCADX policy, which is basically FIFO,
Right.
with a built-in idle CPU selection policy. But there's just one default. What if we introduce multiple defaults?
Could do, I mean, like I said, I'm open for anything. I'm open for throwing this all into a libQOS. I'm open to this. I'm not married to this idea. I went and threw, like, let me go to the most extreme idea, and then maybe just get something close to what. Okay, I'm using the art of the deal. Sorry.
But for instance, I mean, the patch were out there on the list, right? And there was almost no review on them. Because
which one?
From Case, the quality of service interface.
Yeah.
The issue was probably partly because it's driven by his Android background. You know? When we want to design something like this, people have to come from different areas and comment on those patches. Otherwise, they just rot there.
Yep.
Yeah, one problem also with case patches was that some of the feature was quite difficult to use out of the current implementation. I have this multiplier in mind, which I mean only means something with the belt.
Yeah, so his interface was driven by his implementation, and that's why probably a lot of people said, okay, no.
I mean, interfaces are hard. You have to come up with proper abstractions.
I agree that.
So, Steve, there's also a second piece to this problem. Once you have the interface and all, you cannot keep introducing a new schedule.
No.
So do you know why, for example, the Y EEVDF was worse than MuX?
No, well, actually, I'm wondering what the EEVDF was worse than MuX. We think it's with the eligibility. So when we removed eligibility, so basically took out the eligibility, so basically things weren't lacing, it dropped down to almost as good as MuX. It wasn't quite as good as MuX, but it dropped very, very close by just removing the eligibility check. So it had to do something with the eligibility check.
Sure, yeah, and that's a specific case, but what I'm also saying is that once you have the interface in place, right, you have committed to going back and say, okay, we need to be able to investigate and actually identify why.
Well, and also one of the other motivations was about this was breaking things up was like when you find a great way of saying, hey, this update, I found a patch that improves my workload tremendously. Say if we improve every single phone tremendously, but also that same patch does a regression on every server load. You know, that was one of the things. It was so hard to get anything into the current scheduler because once you add something, you basically everything that helps your benchmark made another benchmark go down. So maybe with an interface that we had a good clear interface and then modify it. So it's kind of like, is there a way to simplify this, to separate it out so actually we could make it improve the scheduler and not be a all season tire for everyone?
I mean, and Thomas,
1 minute.
a few years back we did talk about that, where maybe time to split out the. When I say low end, I mean smaller systems versus the big systems.
I don't think it's that simple because a lot of the server workloads also very much care about latency.
Yeah. They care about latency, but the question is it as much, well, they do on like response from like networking cards and stuff like that.
Also, I would say several workloads, it's very broad spectrum.
Yes.
That is very interesting.
Yep.
So it's hard to say one standard to service.
Well, that's why, like, I'm also still have in my slides there, I still had SCEDX, so you could actually tweak if you had to for your specific environment. I know they hate that, but still. The thing is, does Apple have servers? Does Apple have servers? Do they do servers?
No, they don't.
Yeah, Apple's don't. I mean, Apple usually just laptop and phones, which are not too dissimilar. So they can actually, it's more like interface applications there. And we're just having a discussion before where everything was mostly focused on latency and not throughput.
Well, that's maybe an indication that even if you divide in interactive versus server, maybe it's already simpler to.
I mean, I have 2 different environments I'm happy with. Like I said, I kind of came with a lot more. Like I went and said, let me go through the home run here, and if I could just get to first base.
But even if you say, hey, let's separate between more interactive and server-oriented workloads, you might end up, if you look at it at the very end, just by cutting off some stuff server people do not care about, whatever. If you have a homogeneous CPU setup, you don't use the whole placement nonsense because you do not care. There's no difference between the cores you have.
Right.
On the other hand, you just end up not using things by turning off the parameters, or they are not enabled because there is no big little on that system, so they automatically disappear at runtime or at detection time.
Anyway, I think the time's up. So
you get naturally by that environment, you remove parts of it, which makes it a different scheduler by definition.
Yeah.
Because you tune out the complete code path, which doesn't affect.
Yeah, but that's not the clear-cut server client. It's more about like what's there in the system, because you have clients with like SMP, right? no big little, no hybrid, no nothing.
Yeah, sure.
And still you will use the simplest thing without EAS and without similar stuff.
Sure, but then you go and say, okay, I'm a client, I need EAS, and the server people might just turn it off.
Yeah, that's so the problem. The interface problem is that the interface is a contract between user space and the kernel, and we can't.
The interface is not a contract. And
yes, it is.
If you read if you read the actual documentation, it says it's clearly not a contract. It's an informational interface.
But still,
I think we can take it offline because we're
studying EAS. Thank you.